right. Hi, everyone. Thank you for joining and welcome. I just want to take a moment again to thank our presenters, John and Mark, for being available and our moderators for working behind the scenes to support this live event. So today we're going to talk about load balancing in Azure. When it comes to load balancing, Azure has a rich and a large portfolio of options. So by now you are familiar with these layers in Draw.io. So we're going to dive right in. On my screen, you are seeing a multi-region design that we've covered in depth in the previous sessions. So you see two regions, region A and region B, East US and West US. And if you haven't watched the recording, we have covered all of this in depth and the link is in the invite. So let's look at the web subnet layer over here. Here you see that I have 3 VMs in the East region and I have 3 VMs in the West region. For the purpose of this session, we will consider these red, green, and blue VMs and cyan, magenta, and yellow VMs as our application that we will load balance. So let's look at all the options. So here you see that we have 6 different load balancing options in Azure. At a high level, we divide them as regional versus global, layer 4 versus layer 7, DNS dependent versus IP anycast. So let's look at the placement of all of these options. So from a placement perspective, we have here we see regional load balancers. Here we see a global load balancer, and off to the side we have a gateway load balancer, slightly different use case, and we are going to go into a lot of depth with the gateway load balancer. So let me just point out all of the load balancers that we would be looking at. So there are 2 that are numbered as 1, which are the internal load balancer and the external load balancer. They are both layer 4. And then we have the application gateway, which is layer 7. Of course, all of these are considered regional. And then we look at the global load balancer. We'll start with number 3, which is the cross-region load balancer. This is a newer one in our portfolio. Then we have the traffic manager, which is DNS based, and then we have Azure Front Door. All of these, of course, are global load balancer. And then we will be covering, we'll be doing a deep dive on gateway load balancer use case as well. So with that, let's start looking at our first load balancer, which is the layer 4 load balancer. Of course, anytime you're looking at the screen, I will make sure that we have the top right-hand corner showing the exact load balancer that we are looking at. Now, there is a lot happening on the screen, so let's unpack the different items that I'm showing on the screen. First of all, there are 2 layer 4 load balancers over here, internal load balancer and an external load balancer. The internal load balancer would have an internal or a private IP, and the external one would have a public IP that's accessible from the internet. And then the important thing with all of these load balancers, it is what we can put in the backend pool. So here you could see that I have the red and the green VM in the backend pool, and I have a red dash line showing that in the backend pool, I cannot have anything that is across the express route in the data center, for example. In other words, your backends have to be in the same VNet where the load balancer is deployed, right? So that's an important item to consider. And from a configuration standpoint, I have put a screen capture, but if you have managed Citrix or an F5 or any load balancers, appliance-based or hardware-based load balancers, the classic items that you would configure are front-end IP, back-end IP, and session persistence. And that's what we offer as well. And from a session persistence perspective, the default persistence is 5 tuple, which gives us a much balanced distribution of the load if you are behind a NATed IP, for example. All right, so let's look at the different user flows. So this dotted lines are showing user flows. So there are two different type of users. One is an external user, this red user. That user can hit our external load balancer directly in both of these regions. All right, and then we have an internal user, the green user that is sitting either on a private connected branch. In this example, it's showing a data center, but it could be any privately connected branch that has routing to the Azure data center. So this user can directly access the internal load balancer. So now let's take a moment to understand the outbound flows. When we did the first session, I took a deep dive into different type of outbound options that are available in Azure. Now it becomes critical to bring this up in this session as well, because the external gateway also acts as an outbound, as an egress gateway for certain type of workload. So for example, if this VM is sitting behind the external load balancer, it can also egress through the external load balancer. I talked about a corner case about this internal load balancer. So for example, let's say that this 3 VMs, red, green, and blue, are behind the internal load balancer. And if they don't have any instance level public IP, they still need a NAT gateway or an external load balancer to egress. So that's an important point to keep in mind when you are using internal load balancer. So I will light up this option again. I want to, speaking of this external load balancer to use that as an egress point, there is an important best practice consideration. So when you use that for an outbound SNAT, you may want to use a prefix list instead of a static IP. So I have called out a couple of best practices to keep in mind. Also, there is a possibility of you running into SNAT port exhaustion with this methodology. So we do recommend NAT gateway, but there is a very interesting metric that you can monitor. So you may want to turn on monitoring for that metric. With that, I'm going to talk about two very important concepts with load balancer, with layer 4 load balancer. One is the floating IP. So floating IP is used for SQL workload balancing, and its primary use is for port reuse. So I have taken this right out of the Azure documentation, and if you have this draw file and you click on it, it will take you to the exact documentation. But I want to take a moment to talk about floating IP and the use case for the floating IP. So when floating IP is enabled, notice how it says after floating IP. So when floating IP is enabled on the load balancer, it changes the IP scheme in such a way that when it sends packets to the downstream VMs, it keeps the front end IP, it keeps this VIP instead of the backend IP of the VM. So in other words, these VMs have to be listening for the VIP, the public front end IP of the load balancer. Now, this technique is used by default in Azure Kubernetes Services, so AKS. When you deploy an AKS cluster with a load balancer, floating IP is enabled by default. So that is the concept of floating IP. And then we have a concept of HA ports. HA ports, the use case for HA ports is with NVA high availability. So we're going to cover this in a lot of depth. We are going to cover this. Oops, let me just make sure I can see the screen. In the future session, I believe it's 2 sessions from now. But remember, we talked about the NVA high availability. There is this classic design called load balancer sandwich design, where you have 2 load balancers and NVA in the middle. That's when you want to use HA ports, where you want to load balance all of the ports and not just one port. So that's the use case for HA ports. And I want to call out one important point, that when you use the load balancer, layer 4 load balancer, it preserves the source IP. If I have time, I'm going to do a demo. If not, I do have a video on my YouTube channel that you can watch, but it will show you exactly how the source IP is preserved. If this user accesses this load balancer, this VM would see the source IP of this user. Right, so with that, we will go into our second load balancing option, which is the application gateway. So notice the number 2 over here, and we will be looking at the number 2 over here. So application gateway is a layer 7 load balancer. So it is typically used for web-based workload. The reason being, it gleans into the HTTP header, and it can do some intelligent routing decision based on the HTTP header. And we'll go into a lot of details of how the URL-based routing works. To begin with, let's look at all of the different backends that are possible. So if you see this blue dashed lines, that is showing you the different type of backends that are possible. So in addition to a VM-based backends, you can also route, as long as you can route to this blue VM across the express route or any kind of private connectivity, it can be placed in the backend pool. So again, as long as you have routing, it can be placed in the backend pool. Same goes here. You can see that I have the Cyan VM across the VNet peering behind the application gateway. And you could also have a cross-cloud public IP or even Azure PaaS services. So again, this is showing you an application gateway in the East region, and this one is the application gateway in the West region. Okay, again, this is still a regional construct. So there are a couple of best practices when it comes to application gateway. If you're going to be scaling, and if you're going to be using the V2 version of the application gateway, it supports up to 125 instances. So you want to ensure that when you size your application gateway subnet, you size it correctly, depending on how much you're going to scale. If you're going to scale all the way up to 125 instances, and then you need 5 more for the reserved ones, you want to have a /24. Of course, there is an optional WAF component, web application firewall component, that comes with the application gateway that you can turn on. And it offers a lot of features, right? So you could, I mentioned auto scaling. You can do URL-based routing, SSL offloading, end-to-end encryption as well. We'll deep dive into one of these features, which is the most common one that you would see, is the URL-based routing. So let's look at how that looks like from a user perspective. So imagine that this user is coming in and using this URL colors.nihalineyogi.org. It could be any domain name. So when it uses that URL, it can access this application gateway directly. Of course, with that same URL, if you just put a domain name slash, for example, red or slash green or blue, and if you put the appropriate pool behind it, the same IP address can be used for different paths in the URL. And same thing goes with host-based routing. So you could have red.domain name, green.domain name, and blue.domain name, and you can have different pools behind it to direct it to the appropriate pool. So quite powerful URL-based routing. Of course, you want to make sure you have your CNAME records set up appropriately. So I've put an example of how this colors green and red CNAMEs are set up. So you could take a look at those as well. Now, another important thing with application gateway is that notice that you can have only one application gateway, and it can be used by internal user as well as the external user. The same application gateway can have a private and a public IP. Also, the session persistent method, application gateway does support the cookie-based session persistence. So, your user sessions can go to the same server. It's also called, sometimes it's referred to as sticky session support, used for shopping cart kind of applications. And lastly, there is a use case for application gateway can be used as an ingress controller, as an AGIC with Azure Kubernetes Services, AKS. So AGIC stands for Application Gateway as an Ingress Controller. There is a link to my blog. I've written a lot about AGIC and AKS, a very detailed blog. So if you want, there is a link to that blog as well. And again, if I have time, I will do a demo of how the XFF header gets written when you have application gateway, because application gateway is a layer 7 proxy, so it will not preserve the original source. All right, so we'll show that in a demo. If not, you could look it up on my YouTube video. So with that, let me just make sure that I have covered all of the important points here. One more item, you will see that in every load balancer, I keep a screen capture of what options do we have for backend pools, right? So IP, VM, app services. So be sure to check that out as well. And with that, I'm going to go into the third option, which is the cross-region load balancer. So cross-region load balancer is rather new, still in preview. It's still a preview feature, so I want to call that out. It is a global load balancer, and it has a concept of home region. So notice how my cross-region load balancer is in East US 2, while my the two load balancers that are behind the cross-region, this and this, they are in East US and West US. However, the cross-region load balancer is in East US 2. So there are certain regions that are available today as home regions. I have listed them over here, but it's important to know that you would need to deploy that in the home region. And then, of course, the backend can be, it has to be a standard public load balancer. The technology that it uses behind the scene is called IP Anycast, and the failover works really well. It actually directs the user to the closest endpoint, and it also preserves the client IP. All right. So let's go to option number 4. Option number 4 is Traffic Manager. We call it ATM, Azure Traffic Manager. There is a lot to see here. So The biggest thing to call out here is it is a global load balancer and a DNS-based load balancer. And from a backend perspective, if you see these dashed lines, all of these dashed lines is showing you the variety of backends that are possible. So you could essentially have a multi-cloud public IP, you could have a load balancer, an app gateway, you can also have something publicly available in your data center, an Azure PaaS service, so quite powerful. I also worked with a customer where we had, in fact, a Citrix, a third-party appliance that can also be behind the traffic manager. All right. Now, I mentioned that it uses DNS, so it is very, very TTL dependent, the time to live for the DNS, and let's understand that a little bit more using with the user flows and why that is important. So let's say that this user, when the user accesses this domain tm trafficmanager.nihalineogi.org, what happens is behind the scene, the traffic manager uses DNS to redirect this client, depending on the routing method, either to this load balancer or to this load balancer. So it actually gives the appropriate endpoint, a DNS endpoint. So notice that Traffic Manager is not in the data path. It merely gives the endpoint, and then the data path is the green flow. So then the user goes directly to the east load balancer, if depending on the traffic method. The default, depending on the routing method. The default routing method is performance-based. So what performance-based routing method does is it directs you to the closest endpoint. And let's talk a little bit about the routing methods as well. So there's quite a few routing methods available over here. I have a screen capture just to kind of talk through some of the common ones. I'll talk about the priority one. The use case for the priority routing method is typically when you have a primary and a secondary, a failover type design. You want to use the priority routing method. So it always goes to the primary data center, and only in the event of failure goes to the secondary one. And then you have the weighted one where you can distribute the traffic across a set of endpoints. Of course, if you put the same weight, it means equal distribution. So that talks about all of the important points. And I also put, an output of a dig command over here, so you can take a look at how it's working end to end. With that, let me do a quick time check for myself here. And all right, so I'll go to the next layer and the next option, which is Azure Front Door. Mark, my colleague, is going to cover Front Door in depth. So I'll just touch upon a few points just for the completeness of this this session. But for Azure Front Door is again a global and operates at layer 7. So if you look at the backends, these dash lines again are the different possible backends that are available to Azure Front Door. And from a user flow perspective, the user gets a very good experience because it attaches to the closest edge location. We have 118 plus edge locations. So you can imagine the user experience that comes with that kind of Anycast based IP routing that it uses behind the scenes. And then there is a use case. You can see that I have these dashed lines showing the backend. We now also support private endpoints with Azure Front Door, and I have a blog written about this with AKS cluster and private endpoint using Front Door. So you could, it's also on my GitHub, so you could take a look at that as well. Now, Mark again is going to cover this in depth, so I will hold off for more on front door right here. So now let's get into the gateway load balancer. So what is the use case for the gateway load balancer? So over here, you can see that the gateway load balancer can be in its own VNet, in its own subscription and a different tenant. So that's where it can be deployed. But let's understand the use case for gateway load balancer. So remember, we talked about NBA high availability. The use case for gateway load balancer is that this design is quite complex. For north-south traffic, instead of having this design, we could use the gateway load balancer to load balance the appliances. In this case, I'm using the two Checkpoint CloudGuard appliances. So think of it as the way to think of this whole design is think of this as your protected workload. This is the workload you want to protect, like the consumer of the service. And then think of this as something that you're protecting it with. And the concept here is that this whole VNet is quite transparent to the user, right? So it's that service insertion, bump in the wire kind of concept. And let me demonstrate that with this flow so you could see what that means. So really, when the user comes in and kind of goes to your protected workload, it has no idea that this whole VNet exists, right? So it transparently gets redirected to these NVAs, and you can get the filtering and the advanced security capability of the NVA. So you might think, how does this work? So now I will say that we are going into level 500 of Azure networking to understand how this works. So again, behind the scenes, what it does is when you deploy these two NVAs, what it does is it establishes two VXLAN tunnels with the Azure load balancer. So if you remember, when you set up the gateway load balancer, it prompts you for two different ports, internal port and an external port. All right, so what that means is, let's say that the external port that you set up was 2001, and the internal port that you set up was 200. What that means is it sets up two VXLAN tunnel with UDP 2001 port and UDP 2000. And these two VXLAN, there are two VXLAN tunnels that get established. So notice now if I light up the inbound flow, notice that the user is at the source IP and it has its own source IP, and the destination is this load balancer. Now, when the packets are sent to these NVAs, if you notice, I did a packet capture on these NVAs, and if you notice, the outer packet and the inner packet. The inner packet is quite secured. This original packet is untouched, and the outer packet is these two VTEP tunnel endpoints. All right, and that's how the traffic flows through it. So this the inner packet are untouched, and so you also notice that there are two VNIs that get set up, and those were also the one in the configs. And those VNIs are the VXLAN identifier, uniquely identifies the two tunnels, 800 and 8801. So again, I want to give a large shout out here to Checkpoint and John for helping me set up this lab so I can share this detailed packet captures and exactly the inner workings of the tunnels that get built behind the scenes. So thank you, John, for your help. Appreciate that. And then you can see this flow that I showed you is the inbound flow coming from the user to the protected workload. Similarly, we also have the outbound flow, and the outbound flow follows the same path, right? So it's that bump in the wire. And if you have worked with NSX and other technology, software-defined networking technologies, there is a concept of service insertion. So that's exactly what's going on with this whole VNet. And John's going to go into a lot of details about how that, and I won't steal his thunder, but how that experience looks like for an end user. So we'll wait for John to do his presentation as well. And then, if you're new to VXLAN, I have written as simple as a blog on VXLAN. Take a look at that. You can set it up with just using 2 Linux hosts, basically to demonstrate this whole encapsulation, inner packet, outer packet. So essentially doing layer 2 over layer 3. Now, 2 important considerations for this is today, we're not supporting this kind of chaining. In other words, having this load balancer chain with the gateway load balancer. We only support it with an instance level public IP and a standard load balancer. It is not supported with application gateway. And again, not south traffic only. We still need the NVA high availability design for the east-west traffic support. And lastly, I will say that we have a lot of variety of partners that are supported for the Great Gateway Subnet load balance for the gateway load balancer. With that, I am going to hand it over to you, John, and thank you everyone for listening.